Hello everybody, welcome to this lecture. Today's topic is human error quantification from experts' opinion, fuzzy set approach. So, we will see little bit of fuzzy number and how the linguistic variable can be converted into fuzzy numbers. Then from linguistic variable using fuzzy number, how we will obtain the probability of human error or human error probability and case study. As you know that getting human error probability is very difficult and most of the time we rely on experts' opinion, and experts are comfortable in giving responses in the linguistic terms, and that is the reason we are adopting fuzzy theory, and we will show you today how fuzzy theory will be applied to convert the linguistic form of probability values to numeric probability values. So, let us discuss little bit of fuzzy set here. What is fuzzy logic? Fuzzy logic, you know that it basically rely on two things. One is that the things what you want to measure, there must be some kind of fuzziness, which is basically ambiguity, or I can say that overlapping nature and also the impreciseness. So, under such information, it is better to adopt fuzzy mathematics rather than the Cripps mathematics. Suppose if we ask a expert that okay, what is the probability that the operator will commit mistake in closing a valve, then it is very difficult for the expert to tell that it is 0.9 or 0.5 or 0.1. Rather, he given the context, he will be able to tell that it is very likely, very poor, something like this. So, such information are represented by fuzzy number, and in fuzzy number there are two important things. One is that the value as well as the membership function. For example, if this is the variable, suppose x is the variable which can take values a1 to a3, and in between let a1 and a2 and a3, these three values you have considered, and then this side is the membership function. That means what is the share that basically a1 within this particular fuzzy set. So, accordingly we will define the variable like this, where y is mu a x, and if it is within this value a1 and to a2, the membership value is this, and if it is a2 to a3, the membership value is this, and if it is either less than a1 or greater than a3, then the membership value is 0. Okay. So, I will not go into that depth of this membership function or the fuzzy values, because it is a very much standard thing now, and if you do not have much knowledge on this, it is better for you to go through a good text like Ross and fuzzy logic, so that there you get the better treatment. But for the time being, what I mean to say that fuzzy number is different from Cripps number. In Cripps number, if I say particular value, the membership is 100%. When in case of fuzzy number, we will say the value is a1, so with certain membership function, or a2 with certain membership function. So, there are different ways to represent fuzzy numbers. The most popular one is triangular fuzzy number, and trapezoidal fuzzy number. In case of triangular fuzzy number, there will be three values a1, a2, a3, and a2 is a value which is having the membership of 1, and a1 and a3 they have basically less than a1 or less, or a1 a3, that value membership value is 0. So, that means the x value lie between a1 and a3. And in case of trapezoidal fuzzy number, you see that the form is, it is a trapezoid, this is the home. So, here what happened, there will be 4 points, this A1, this 4 vertices, you can say this one, this and this. So, everywhere there is a value for x, this x is the fuzzy number. So, A1 with membership value 0, A3 with membership value 0, but in between when it is A2 membership value is 1 and A3 membership value is 1. So, in between the membership values will be less than 1. So, then when we are talking about trapezoidal fuzzy number, you will be using this kind of mathematical form. Okay. So, today what we will see now, that using the trapezoidal fuzzy number, how the linguistic responses given by the experts will be converted to probability values. As we are dealing with human error, so our discussions ultimately or all result in all calculation ultimately gives you the human error probability. But this is a general topic, the mathematics is generic one. So, it can be applied to any kind of linguistic variable the responses are given by the experts. Okay. But for our context, it is human error, and we are asking the expert, you tell the probability or possibility of committing errors by the human given the particular type of errors. Okay. So, you all know what are those errors. So, there is a scale. Suppose you are going for linguistic variable with and converting to fuzzy number, then there is scale. Now, this is linguistic variable, very poor, poor, medium, medium good, good and very good. Such kind of things will be there. So, if I want to say that in terms of probability, if I ask that what is the probability of committing error, when we are saying very good means it is basically very, very high. So, good means high, medium good means medium high, then medium low, then low, then very low. So, the very poor to very good, this is given by, the scale is given by OSHA. So, you have to make change to suit the context. And if it is very low probability and you are using trapezoidal fuzzy number, then you have seen already, suppose this is my, let us consider a trapezoid like this one, this is the first one. So, in this case, what is A1? A1 is 0, what is A2? A2 is 0, what is A3? A3 is 0.1 and what is A4? A4 is 0.2. So, this is what is given here 0, 0, 0.1, 0.2. So, that means if the response is very poor or very low, then this is the representation in terms of fuzzy number. Okay. In the same manner, the second one 0.1, 0.2, 0.1, 0.2, 0.2, 0.3, this is my triangular fuzzy number, because these two are same 0.2, 0.2. Suppose if you consider the third one 0.2, 0.3, so you start from 0.2, then 0.3, second vertex is 0.3, then 0.4 and then 0.5. So, then this particular response is represented like this. If your response is medium low or medium, then this is the fuzzy trapezoidal fuzzy representation. So, what you will do, you have already seen that using Tharp, and we have actually in previous lectures like Tharp, Hart and then Sherpa, and we have identified different kinds of human error modes. So, all those modes, when it is given to the expert who knows the totality of the situation, then what he will give value, probability or possibility values in this form, either very low, low, medium low, medium, then medium high, high and very high. And then the scale is given by OSHA. What you require to do? You require to just convert this very low to this or very poor to this and very good or very high to this, and accordingly the graphical representation is this. So, that means this is basically the data coming from the expert in terms of linguistic variable converting to fuzzy variable, fuzzy numbers using the trapezoidal membership function, and the scale is given by OSHA. So, let us see next what we are discussing. Now, let us think of checking error. Okay. So, given a particular inspection, you have to check whether there is defect or not. So, while checking you may commit mistake. So, hypothetically we are saying this error mode is E1. This is basically the error number in a particular mode. It may be checking error, it may be action error, it may be selection error, it may be inspection error, but you have several such errors you have identified from the task analysis. Then what happened? You have given this particular error to 3 experts, expert 1, expert 2 and expert 3, and you ask them, you tell me what is the linguistic possibilities values. So, let us in this form very poor to very high, and the analogy with the probability I have already explained. Suppose the expert has given, first expert given it is very poor, second one says that the error mode occurrence is poor, and third one given as very poor. So, 2 has given very poor and 1 given as poor. Then if it is very poor, then which one? This. So, this expert 1 given 0, 0, 0.1, 0.2, expert 2 given 0.1, 0.2, 0.2, 0.3 and expert 3 has given again 0, 0, 0.1, 0.2. Okay. So, this is basically the what way these fuzzy numbers from the linguistic responses of the experts, and this is what is the mapping. Okay. So, you have to do first this. Then in fact, I should give you the steps first. So, how to obtain probability using the fuzzy numbers? First step, select appropriate linguistics evaluations, I have already explained, and corresponding membership function. Then obtain possibilities from experts, that very poor, poor or very high, very low, like this. Third step is compute similarity of the views between the each pair of experts. It is important because 3 experts are or 5 experts or even more experts, usually 3 or 5 is better. So, 3 experts are chosen and they were given this context and the error modes also given to them. You are asking that what is the possibility that operator will commit mistake or commit error. So, under such situation, if the experts are really experts, it is quite possible that they will give you more close values. So, that is the similarity of views. So, given the expert responses, find out the similarity of the views. Then fourth step, after similarity calculation, you find out the average agreement degree of the expert. So, every expert how they are agreeing with the other experts. After that, you find out the relative agreement degree. Then after that, you compute the weights of the experts, because all experts are not equally expert. So, there will be differences. So, that differences also you have to consider. So, consider the weights. Then using this relative agreement with weights, you compute coefficient, which is basically consensus coefficient. So, once you have consensus coefficient, then you will be able to find out the aggregated value of expert judgment, and then this judgment you will be getting in terms of trapezoidal form. So, you require to dephasify this one and then you will get a Cripps value. That Cripps value with certain certain equation will be converted to human probability values. So, very quickly I will show you each of the steps now. Step 1 is this: identify all the error modes. For every error mode, ask the expert to give their opinion. So, error mode 1, 3 experts opinions are given. 3 experts opinion like this. Okay. So, then from the fuzzy scale you found out these values. This is the first. Second one, similarity of the views. How do you know the experts are similar? So, that will be known using this formula. So, calculate degree of agreement by similarity agreement method. The formula is this. So, how many your experts are there? There are 3 experts. So, how many values are there? For trapezoidal case, there are 4 values. So, use this equation, and then using this equation and the data from the fuzzy that numbers, that is basically from the trapezoidal membership you got, these two, when these values when you put in this equation, then you will be finding out the similarity between expert 1 and expert 2 is 1 minus 1 by 4, then 0 minus 0.1 you see. Then we are talking about similarity between these two. So, 0 minus 0.1, 0 minus 0.2, 0.1 minus 0.2, 0.2 minus 0.3. We are interested in the difference. So, we that minus plus all are same to that is why you put the mode value, the absolute value, and using this formula now you got the similarity or degree of agreement, which is 0.875. So, in between expert 1 and expert 2. Similarly, you can find out expert 1, expert 3 and expert 2 and expert 3. So, expert 1, expert 2 similarity value is 0.875, expert 2, expert 3 again 0.875, expert 3 and expert 1 is 1, because you see they are same values, giving same values. So, that means experts responses for every error mode is used considering here trapezoidal membership function, similarity value is calculated using this formula. You just practice, it is not a tough task. Then you find out the average agreement degree of the expert with all others. So, what you got? You got the similarity value, use this formula, then find out the average agreement degree. Okay. So, average agreement of expert 1 with other experts. So, what is required to be used? How many experts are there? 3. So, 1 by d minus 1, 1 by 3 minus 1. Then this is the similarity value between expert 1, expert 2 and expert 1, expert 3. Expert 1, expert 1 is not required, and expert 2, expert 3 also not required, because we are interested to find out the average agreement for expert 1. So, as a result you will be considering 0.875 and 1, and using this formula you are getting average agreement for expert 1. Similarly, for expert 2, similarly for expert 3, and this is the calculation. Okay. Understood? So, using this formula find out average agreement, then let us see what is next. Next is relative agreement. Relative agreement is again another easy concept. That means the agreement sum your first expert experiment divided by the sum of the agreement of all the experts. That is what is done here. What is the agreement for first one? 0.9375. What is the sum? This plus this plus this. So, denominator is the sum of all those agreements, numerator is that concerned expert agreement, then relative agreement for expert 1 is this. This is done so that ultimately the agreement, relative agreement of all the experts will be sum to 1. So, this is our, now we will go for the next step now. Next step is, once you have the relative agreement for each expert, find out the weight of the experts. So, for weight of the experts, Nikokis and Suda 1985 given this scale. What is this scale here? They have considered professional position, service time, education level and age of the expert, and there are different classes of professional position, different service time, different education level and age, and some scores are given. These scores definitely based on certain scientific measurement, either may be through expert opinion or through simulation or through field studies. So, then in our case we had 3 experts, expert 1, expert 2, expert 3, and their details on those first, second, third, 4 different criteria, 4 different I can say features. So, junior academician will get 4, so like this. Master degree you it will be 4, so like this 4, 4, 3, 3 it is total. So, weight for expert 1 is 14, weight for expert 2 is 9 and weight for expert 3 is 13. This basically we calculated from this, from the data given Nicholas and Tsuda. So, now you have to find out these weights, normalized weights. So, normalized weight will be individual weight by the sum. So, 14 by 36 is 0.39, 9 by 36 is 0.25, 36 by 13 by 36 is 0.36. So, this is experts weights. So, it is how it will be explained? It will be explained something like this: expert 1, expert 2 and expert 3, if you compare, then expert 1 and expert 3 they are almost equally expert, where expert 2 is having little less expertized. So, that is what the weight. So, relative agreement is known to you for a particular error for the 3 experts. Now, experts weights are also known. We will use this to find out consensus coefficient. Consensus coefficient means how the experts ultimately what is the consciousness, in the sense how much, what is the agreement they have made here. So, we use this formula 0.5 into the weight of the expert, 1 minus 0.5 into that relative agreement. If you this is known, this is known, and finally for, and this is the relative agreement is known, weight is known, these two combined will give you this using this formula. So, 0.5 into this, 1 minus 0.5 into this will give you these values. So, this is basically consensus coefficient amongst the consensusness amongst the experts. So, for every expert consensus coefficient is found out. Using consensus coefficient, you go for the next step. In the next step is basically the aggregated result of the expert judgments. So, now see, you have the consensus coefficient, and you for the error mode U1, the 3 experts and given these values in terms of fuzzy numbers. Just what you are finding out? You are finding out the aggregated result using this. So, this multiplied by this plus this multiplied by this plus this multiplied by this is nothing but this. So, similarly, second one, third one and fourth one, because it is the trapezoidal fuzzy number. So, 4 vertices are there, 4 points. So, all those values calculated here. Okay. Now, what you do, this is to be defuzzified. So, how you will do the defuzzification? Defuzzification will be done using the center of gravity rule. So, that formula is this. minus S1 S2 plus S3 S4 1 by 3 this S4 minus S3 square minus 1 by 3 S2 minus S1 square divided by S3 plus S4 minus S1 minus S2. Then S1, S2, S3, S4 these values are known to you, already computed aggregated values. So, these values once you put here, the defuzzified value is this one. So, that means the defuzzified value for error you got, error mode. Using this we will go for to the next, that is basically how to find out the probability, human error probability. So, this one is written here. So, Onisawa 1988 given this formula to calculate the probability. So, HEP 1 by 10 to the power k, k value already you have U1 defuzzified value is this. So, where k value will be this value. Now, 2.301 are multiplied with the defuzzified value 1 minus defuzzified value by defuzzified value to the power 1 by 3, and then after you got this k value, put in this equation 1 by 10 to the power k. So, k value is our this, once you put into this formula we got this is the error probability. So, that means for the human error mode U1, it can be anything, checking error, inspection error, counting error, whatever, anything, operation error. So, that error when you have the expert judge values, and you please take at least 3 expert, and then you use these steps what I have given to you, and then finally come to the probability of committing human error mode E1 is this. That is what is the thing we want to calculate. I hope you have understood it, and there is a case study, but I do not want to show this case study now. If time permits, we will show you in some later classes. So, what is this case study known to you? This case study is nothing but the crane study, and then we have done task analysis, then finally using this all the error modes we have found out so many error modes, and then we have collected the expert opinion. Here we are showing only this portion, that inspect lower part, what are the different task elements and what are the different error modes that happen, and then with this the 3 experts opinion we have taken, we have converted to the fuzzy values, then finally all the calculation what I have explained so far is used, and then the error probability values are computed. Okay. So, this is interesting one, and I very hurriedly I can say that very quickly I have completed this one. I hope that you have you really understood it. If not, please put in the discussion forum. Maybe in next class I will revisit it if it is required. Please put in the discussion forum. Thank you very much.